Self-attention, a crucial building block of transformers architecture in neural network. In this video, we will go through the key concepts of self-attention. The main idea here is to attending to the most important parts of an input, that is, identify which parts to attend to and extract the features with high attention. The input could be natural language or image. In this example, as a human, we can distinctly identify that there is a dog in the image. But for a computer, it needs to sequentially process all the pixels to try to identify what is in the object. The desired capabilities of the sequence modeling systems is that the system needs to handle continuous stream, it needs to handle the parallelization of the tasks, it needs to handle long memory. One option is RNN, but the major limitation is it's slow and cannot be parallelized. The idea of self-attention started from the paper Attention is All You Need, where the authors demonstrated that the use of transformer architecture hugely increased the performance of machine translation. After its huge success, this idea has been transformed to other domains like images with Vision Transformer in 2020. The self-attention works in 4 key steps. The first is to encode position information. In the example here, he tossed the tennis ball to serve. In this text, we create the embedding of each word. We add the notion of position information to create position-aware encoding. In the second step, we extract query key value. We create the 3 copies of positional embedding. We multiply it with 3 distinct linear layer and we get the query, key and value. In the third step, we compute the attention weighting. We get the similarity score. We multiply query with key and then scale it to get the cosine similarity or the similarity metric. The output of it, then we input it to the softmax to squeeze the input to a valid range. The graph here is a heat map and it shows the attention weighing between each words. As the final step, we extract features with high attention. We multiply the attention weighing with the values and we get the output. So we get the features that has high attention weighting. We will show an example code. We retrieved it from the GitHub URL mentioned in this slide. It uses the Vision Transformer with pre-trained weights from the model VIT B16224. In this example, we get the attention map for the original image on the left. So on the map 1 layer, it tries to get the attention, it tries to extract key features, and iteratively on consecutive layers it learns new features, and on 12th iteration it learned that the key feature of the dog in the image is around its face. There are many existing applications of self-attention, the most promising one being BERT and GPT-3 in natural language processing, which are trained in large corpus of text data on biological sequences, AlphaFold 2, on computer vision transformers. People are studying the theoretical limitations of self-attention, but apart from that, the transformers has huge potential. It's an active area of research. The real world data is very complex and many research is being conducted to reach near human level intelligence. Self-attention is one step towards achieving this cognitive knowledge. And this did not stop here. One of the upcoming application is GPT-4, where they try to get human level cognitive intelligence, and this process will continue. Thank you.